All right, we are going to be factoring today, so it's lesson 5 for factor linear expressions. Factoring is basically like undoing the distributive property. Okay, so I'll give you an example of distributive property. Let's go 2 times x plus 3, and that would equal, we distribute that in, 2 times x and 2 times 3, and we get 2x plus 6. Okay, most of you are pretty good at distributive property. What factoring is it's going backwards. It's saying, what could I pull out? What could I pull out of the 2 and the 6? Like, what's a common factor? See what's going on here? We're pulling out factors, common factors. So, like, 2 goes into 2 and into 6. So we can pull that out. And then we say, okay, well, what times 2 will give us the 2x? Well, we need an x there. And what times 2 will give us 6? We need a 3 there. So that's the premise behind factoring linear expressions. It's like undistributing, or the reverse of distributing, figuring out what it would have been before something was distributed. Okay, so here's a little vocab that'll help us. Monomials, basically, they're the building blocks of an expression. All right, so monomials could be a number, a variable, or the product of a number and a variable. So there wouldn't be any addition or subtraction signs within a monomial. So for instance, here are some examples. It could be a variable, a number, a product of numbers and variables, right? Numbers and variables products, numbers and variables products. Notice there's no addition or subtraction signs within those monomials. These are not monomials. Why is this not a monomial? Because of that plus sign. Here you have a minus sign right there, so that's not a monomial. Here you have a plus sign and a minus sign, so that's what makes them not monomials. All right? So, to factor. Factoring, the word factoring, means to write it as a product of its factors. All right? So if we break 24 into its prime factors, that means we're going to keep breaking each of these factors of 24 down until we only have prime numbers, or numbers that are only divisible by themselves in 1. So 24, we can kind of do this little factor tree here. We can break that into 2 and 12. Now here is a prime number, so we'll stop with that, but we can branch this one off further. We can go 2 and 6, right? 2 times 6 is 12. 2 is prime, we'll circle it, but 6 is not prime. We can still figure out other factors besides 1 or 6. So we can branch that out into 2 and 3. And now we have it all broken down into just the factors that are prime. So the prime factorization there would be 2 times 2 times 2 times 3. And if we calculate that out, 2 times 2 is 4, times 2 is 8, times 3 is 24. So that is 24 broken into its prime factors. The numbers that multiply, the prime numbers that multiply to get you 24. All right, boom. So another way to write this is 2 to the third times 3, because there's 3 factors of 2. Anyway, that's the prime factorization. If we want to break up 4x plus 2 into its factors, that's a little bit different. All right, and that's what we're going to be focusing on today. So what we would do is we would say, can we fill in all these blocks? What could I distribute in to a linear expression in the parentheses here to get 4x plus 2? Well, we can look at the 4, we can look at the 2 and say, 2 goes into both of those. So what would I multiply by 2 to get the 4x? 2x. And what would I multiply by 2 to get the 2 here? 1. All right, that's our goal for today, is to be able to break up these expressions, not monomials, but expressions, because that is a plus sign, into its factors. Okay? So right now we're going to first do the greatest common factors of each pairs of monomials. So we're trying to figure out what goes into 4x and 12x. So let's go. All right, we're going to draw a little like downward division sign there. Everybody do that in your notes. Okay, then we're going to think of numbers that go into both 4 and 12. Off the top of my head, I can think 2 does. Now we're going to downward divide. So we're going to do 4x divided by 2 is going to be 2x. And 12x divided by 2 is going to give us 6x. We're going to keep going until we can't think of anything else that goes into those numbers. So what else goes into 2x and 6x? Well, we can get another 2. All right, so 2 goes into 2x, and we'd have 1x left, and 2 goes into 6x, we'd have 3x. All right, can anything else go in? Well, they still share a common factor. This is a tricky part. Remember, factors are just things that are multiplied. Well, both of these x's are multiplied, right? Both this x and this x are both being multiplied. They're part of this product here. So we can pull that out as well. And then what we have left is 1 and 3. Okay, so now 1 and 3 are prime. You can't put anything into either of them besides 1. All right, so we are going to then circle these 3 numbers, and that is our, put the multiplication symbols in here. This is our GCF. Okay, those numbers down along the side of the downward division. So we get 2 times 2 times x, which can simplify into 4x. Okay, so that is our answer for this. It said find the GCF of each pair of monomials. Well, our GCF is 4x. Let's do example 2. Let's find the GCF of these monomials. Well, we're going to downward divide. Can you think of anything that goes into 18 and 20? Well, they're both even, so I can pull out a 2. So I get 9a and 10a. Does anything else go into 9 and 10? No. But is there still a common factor for those monomials? Yes, we can do a. Okay, and that gives us 9 and 10. So what is our GCF? Our GCF is right over here. So 2 times a, or 2a. Keep it moving. Good work so far. All right, numbers can get a little crazy. They can get bigger and more difficult, but if you continue to use simple divisibility rules, you should be able to manage. So we're going to find the GCF of these monomials here. What goes into 12CD that also goes into 36CD? Well, I see 12 and 36. They're both even, so I'm going to take out a 2. That gives me 6CD. And 36 divided by 2 is 18CD. What else goes into that? Oh, they're still even, so I'm going to do a 2. 3CD and 9CD. Ooh, okay, I still got more to go in. I'm going to pull out a 3 here. So 3, because 3 goes into 3 and 3 goes into 9. 3 goes into 3 once, CD, and 3 goes into 9 3 times. Now the numbers are done. 1 and 3 are what we call relatively prime. Nothing goes into both of those besides 1. So now we can work with the variables now. Do they have a common variable? Yes, they have C. So we get 1D and 3D, and they have the D, so let's go 1 and 3. Now they have nothing in common anymore, no common factors. So we're going to circle this over here. That's our GCF, so that's 2 times 2 times 3 times C times D, which this simplifies. 2 times 2 is 4 times 3 is 12CD. That's our GCF. Okay, now some of you will be able to look at the 12 and the 36 here and say, oh, I know what goes into that. 12 goes into 12 once, and 12 goes into 36 3 times. So you might be able to do these GCFs mentally for some of them, but this downward division is a good backup plan in case you can't figure it out mentally. Okay, you can do it little bits at a time, and that'll help you. All right, so there you go. We're looking for a greatest common factor. All right, so these ones you can do on your own. Pause the video, try them, and then unpause and see if you got them right. All right, here are the answers. And first one is pretty straightforward, except you might have put C in the answer, but notice how they don't have C in common, right? They don't, both monomials do not have a C. so they're not in common. So it wouldn't be part of our greatest common factor. Okay, now in the second example, or the second got it, they have an x and an x in common, but the y is not in common. They don't both have a y, so that's why there's no y in the answer. All right, and in the third one, they have an m and an n, m and an n. They both share those. They have them in common, so that would be part of your answer. See, m and n are both in the answer. Okay, so adjust those, learn from your mistakes if you made any, and now we're moving on to the main purpose of the lesson. This is factoring. So when it says factor, this is not a monomial anymore. It's a collection of two monomials divided up by a plus sign, or split up by a plus sign. Okay, so what we're going to do is we're going to take 3x plus 9, and I have kind of two ways to do this. All right, one is with downward division, 3x plus 9, and what we want to do is try to figure out a common factor between those two terms, or those two monomials. So what goes into 3x and 9? Well, 3 does. If I divide that out, 3 times what is 3x? Well, 3 times 1x is 3x. Plus, and 3 times 9, or what times 3 is 9? 3. So we do that same downward division that we did up here. All right, but now our answer isn't just going to be this 3, okay? That's going to be the number that goes out front, okay? That's going to be the number that goes here in our answer. And then this is going to go in the parentheses, so that's going to be 1x plus 3. And that is our final answer for our factoring. Notice it looks like distributive property now, right? The 3, if I distribute that back in, 3 times 1x gives me the original 3x here. Okay, and then if I distribute that 3 to the 3 over here, 3 times 3 is 9. That gives me that 9. Okay, so this whole expression here is my answer. All right, the other way to do it is just to set up a little standard, like what do you call it, just like this little format here. It's almost like a formula for it, and you find your GCF right there. So your GCF always goes in front of the parentheses. So now you look at 3x and you look at 9 and you say, what goes into both of those? I know that 3 goes into both of those. Then I ask myself, well, 3 times what would give me that 3x? Well, I need an x there, or a 1x. And 3 times what would give me 9? Well, 3 times 3. Okay, and then it's just a mental math thing where I'm just trying to work out what was it before it was distributed. All right, there we go. I'm feeling good about this. Hopefully you guys are too. Ooh, now we're throwing in a tricky one because it says factor. So we're breaking it up. We're kind of undistributing. Undistribute. All right, that's what we're looking to do. But the problem here is you might look at these two monomials, or these two terms, and be like, wait, what do they have in common? 12 and 7. Well, 7's prime. Only 1 and 7 go into it. So, and neither of those go in. Well, 1 does, but 7 doesn't go into 12. So if you can't find anything that goes into either of them, then we call it not factorable. And that's our answer. Okay, because we can't think of a GCF. Okay, these two have no GCF other than 1. All right, okay, moving on. All right, so now we're going to factor these. So I'm going to do it with the downward division. So I'm going to say 4x minus 28. I'm going to look at those two terms and think, what goes into both? Well, I know, let's see, 2 goes into 4x and into 28, so I get 2x minus 14. Oop, should that be my answer? Should I just write down 2 times 2x minus 14? No, don't do that. Don't do that, okay? Because I can still factor something else out of 2 and 14. I can do another 2, okay? So that's going to give me 1x minus 7. If I circle those, that's going to give that number, right, I'm multiplying. That's going to be 4, and This is going to go right here, so that's going to be 1x minus 7. That is the factored form. Factor each expression. All right? So I get my GCF, and I place my GCF right in front of the parentheses, and then whatever's left after I pull my GCF out, divide out the GCF, I put in the parentheses. All right, let's try this next one. 3x plus 33y. I'm going to divide out, let's see, what goes into both of those? 3. So I get 1x plus 11y. Do they have anything else in common? No. So I put this in front of the parentheses, so I put my 3 out here. And then this goes inside the parentheses, 1x plus 11y. All right, and there's my answer. Last one. So 4x plus 35, downward division. Now I'm racking my brain. I'm like, what goes into 4 and into 35? They're not even, so it can't be 2. 35 is not even, so it can't be 2. And I'm still thinking, I can't figure it out. Oh no. So there is none, so I'm going to write not factorable. There we go. All right. So we're cruising. Hopefully, hopefully that makes sense. Hopefully you got all that down in your notes. Good luck, and I'll be there to help you with the lesson another day. Hopefully it all clicked for you. If not, we'll get you there. Don't give up. Persevere. Woohoo.